So when trying to find the area between these 2 points and between these 2 curves, I at least know this point. That was given to us by the problem. It's minus pi over 2. But I need to know this one, sort of. Now, one thing I could ask you to do is just do this one numerically, in which case we need to integrate from this point to this point. Let's just call that x. Top minus bottom, right? So it's going to be cosine of 2x minus sine of x dx. And like I said, I don't know what this point is. I don't know what that is up there. I need a number. Now, some of you might know it from your work with trig. That's fine. Let me go back here to the graph. You remember what we did to find this earlier today? The point of intersection. You hit the second key, then the trace key. Second key and the trace key. We want to find their point of intersection. So just take that cursor and get it close to the point of intersection. It doesn't have to be right on it. And you're going to press enter a total of 3 times. One for the first curve, one for the second curve, and one more just for good luck.
What's the point of the guess?
The point of the guess, I think it goes back to the numerical analysis, that they want you to get closer just so that it doesn't take as many iterations to run through the formula. It doesn't really matter. You can just keep on pressing enter. So this is our point of intersection. Now the good thing for us is that point is now stored in x. And I can actually use that in my numerical integration. So I don't necessarily need to know that that's pi over 6, for instance. I can integrate this. And let's try and make the integration a little bit easier. So go to the math menu. Math menu. 9th option down is fn int. I want to go from negative pi over 2. So minus key on the bottom row of your calculator, or the opposite key. Negative pi over 2 up to where? Up to x. We can get away with that here. X has that value of 0.52 something, that point of intersection. X is really going to get a lot done for us. Now, you can either type in this function, cosine of 2x and sine of x, or let me show you one last little trick here that can make your life a little bit easier. Instead of typing in those functions, we've already typed in those functions into our calculator, right? They're in y1 and y2. So what I'm going to do here is I'm going to type in y2 minus y1. The cosine was in y2, the sine was in y1. You can access that from the vars key. So vars, hit the vars key, it's right underneath your down arrow, a little bit to the left, next to the clear. And then go to the right one for y vars. That's the one you want. Vars, y vars. If you press enter, you see all your choices. So are you with me here? Let's press the number 2. That gives you y2. Minus, now we got to repeat that to get y1. So vars, y vars, function. This time I'm going to press the number 1. And finally I'm integrating with respect to x. Now it's not going to confuse that with the x value that we put in here for the limit of our integral. There you go. Should get 1.299, etc. Now if you're really, really gung-ho and did that out longhand, you'd end up with 3 square roots of 3 divided by 4. But if all I ask you to do is do it numerically, then you should be able to get about 1.299, etc. How are we looking on that numerical one? All right.
What was the x min and x max? Was that pi over 4?
Yeah, x min was negative pi over 2, and then pi over 2 for x max. Yep. Last one for this section. That's going to be problem 34. And again, I just want to look at this one to point out something about how you would calculate it if you did calculate it. Let's see, 5. So I have that one up here. No, it's not that one. Not that one. No, not that one. Ah, phew. Good. Let's zoom out here. So here's problem number 34. We want to find the area between these two curves. Y equals x to the fourth minus 9x squared, and y equals x cubed minus 9x. So those two graphs are drawn for us right here. You could also graph these on your graphing calculator, but you'd have to be kind of careful if you're trying to find the area between these two curves, because there's really 3 different areas. And let me kind of zoom out a little bit, or zoom in a little bit. There's the area between these two curves, in which case this is top and this is bottom, and then that changes. You get this little area in here, and then this area over here. So let's see if we can't do that numerically, keeping in mind that the blue function is x cubed minus 9x, and the red function is x to the fourth minus 9x squared. Let's put those into our graphing calculator. So go back here. So x to the fourth minus 9x squared, and x cubed minus 9x, like that. Now you could, if you wanted to or needed to, take the time to graph that. I've already got the graph, so I'm not going to do that. Instead, I'm going to start working on trying to find the area. So the area between these two curves gets a little tricky for one reason. Can maybe somebody articulate that reason? Why does it get tricky to find the area between these two curves? Good. Not symmetrical, different curves. Keep going. Yeah, the top and bottom functions flip-flop, don't they? Right? So you kind of have to look at this in 3 different intervals. So the first interval would be from -3 to 0. That's the first interval. So let's see here. So I plug this in. Let me show you my calculator. Oops, wrong one. So y1 is this function. y2 is this function. I'm going to find my first area, and let's shade that first area here. I'm going to find that first area by integrating between -3 and 0. So let's do that. -3 to 0. And what was the top function? Was it y1 or y2? Top function, yeah, it's y2. So it's going to be y2 minus y1. So let's do that. Integral fn int from -3 to 0 of y2 minus y1. Vars, y vars function, y2 minus y1. Oops. and integrate that with respect to x. So I get 52.65. 52.65. And next I need to pick up that little area in the middle. So that's this one right here. What's going to find that area for me? What should I integrate? Good. y1 minus y2 from 0 to 1. And we're going to cheat because we're going to make this really easy. I want to get this problem done with. So we're going to cheat this way. I'm going to hit the second key, then the enter key. And the nice thing is that it brings back my previous calculation, right? All I'm going to do is change the limits of integration. My limits of integration now are going to be between 0 and 1. So 1 here, and let's make that a 0 now. Second key, then enter. We'll pull up your previous calculation, and then you can edit it. Now, the one thing that you got to keep in mind is if I did it this way, my top and bottom function are really in the wrong order. But what's the effect going to be on the answer? It's just going to make it negative. So we'll make it positive when we write it down. Is that what you're going to say? Yeah, that's another way to do it. Yeah, good observation. You can just flip the limits of integration. So a couple ways you can handle it, but we get 1.45. And the last piece here, plus the integral from something to something, it's going to be y2 minus y1 dx. Let's look back at our graph. What's the last set of limits going to be? So on the x-axis from 1 to 3. So from 1 to 3. And let's do that for our calculator. So again, hit the second key, then the enter key, and then just go back and change your limits. So from 1 to 3. 13.6. Someone want to do me a favor and add all those three up? Let's see, it should be 15.05, 67.7? 67.7? All right, good. So, there we go. For homework, try 1 through 11 and 15 through 39. Please get comfortable doing some of these things numerically. I think in a modern kind of computer age that, I'm leaning more towards doing more and more of these things numerically. I'm not sure that a lot of people actually do all this stuff by hand anymore. So, but your classes above you are going to require that you be able to do things by hand. That's why a lot of it's going to be that way. But I am going to show you some shortcuts and some ways to at least check your answers. All right, there's nothing wrong with checking it. I hope you do.